Good morning once again. I've been trying to, I think I need to turn on the mic. Okay, so I've been forgetting to turn on the mic. I guess this time around you're able to get me clearly. Okay, just confirm you're able to get me clearly. So last time we were looking at variation. That is the part we were looking at, or the part that was recorded, but unfortunately there was no sound. And I guess this one, the leads sound. Okay, so let us just redo the part that actually wasn't successful last time. And I guess this time around you're able to get my audio. I think that's very important. Able to get my audio. I think that's very important. Okay, I think yeah. All right. So variation. What is variation? What is variation? So variation is just the relationship, or it involves the relationship between variables that change in relation to each other. So the relationship between the variables that change in relation to each other is what we call variation. So the definition, you need to know it, though not applied in terms of calculations. But I think it's very important in mathematics to know the definitions. Anyway, the types of variation that are there, we have what we call Dirichlet variation. So now for the variables, just to mention it, for the variables, you are looking at any letter of the alphabet anyway. So it can be X, can be Y, can be Z, can be A, can be B. These are called what? Variables. So when you have Dirichlet variation, we are saying this is a type of variation where if you have one variable, let us say Y, varies, this is what you use for varies, directly as X. What it means is that as one variable is increasing, so is the other one. And of course, the increase is happening at a constant rate. Okay? It's happening at a constant rate. Or when one is decreasing, also the other one is decreasing at a constant rate. Okay? So that is what we call Dirichlet variation. So in terms of the formula, we can say y varies directly as x, but of course in front there's always a k, which is called constant of variation. Now, example here, given that y varies directly as x, and of course y varies directly as x, y is equals to 6, x is equals to -3. So given that y varies directly as x, when y is equals to 6 and x is equals to -3, they are saying find the value of k, which is the constant of variation. So how do you find the k? And normally, maybe just to put this one across, normally the information that is given in the first part right here is used to find k, which is constant of variation. So we know that for Dirichlet variation is that y, here we have y, varying directly as x. So there's k, x, like this. Let us find k when y is 6, x is -3. So you just replace. So this is 6 is equals to k -3. Divide both sides -3, divide both sides -3, and you find k to be -2. That is our k. Okay? So that is for Dirichlet variation. That is for Dirichlet variation. Okay. Another type of variation is called inverse variation. Now for inverse variation, let us say you have the variable a and b. If they are varying inversely, it means that when one variable is decreasing, the other one is increasing. But this one is happening at a constant rate. So when one variable is increasing, the other one is decreasing at a constant rate. So we say, let's say a varies inversely as B. And of course, the formula for this one is K is Y varies, or Y is equals to 1 over, why am I saying Y? Is A is equals to 1 over B. Which can be written as A is equals to K over B. So this is what we are going to go with. Now, like I said, you have to find, most of the question you find, the first question, find constant of variation. This is what we are going to use. So find K when A is equals to 9, B is equals to 3. So A is equals to 9, B is equals to what? Is equals to 3. So to find K, we are just going to replace where there's what? We replace where there's 9, where there's A with 9. So we're going to say 9 equals to K. Where there's B, we replace a 3. Here we can cross multiply and have K is equals to 9 times 3, which is 27. So our K is equals to 27. Okay. Now they are saying find the value of B when A is equals to 6. Let me just make some modification here. So instead of saying 6, I'm going to put this one as 9 so that we don't have the decimal. So how do you find B? So the same one. So after you found K, replace it where there's K here. So you're going to have A is equals to 27 over what? Over B. This is what we are going to go with in calculating the next questions. Okay. So now let me just clear this part. We know that K is 27, which is already there. So I say find B. Is it find B? Find B. Yeah. So A, in this case, what is our A? A is given as 9, like I said. So 9 is equals to 27 over B. So you cross multiply here, you're going to have 9B equals to 27. You want to get rid of 9 so that you can just remain with B. So therefore B, it gives us 3 as the answer. Okay, I guess someone has picked something up to this point. As we proceed, let me just check people that might be part of it. Okay. The other type of variation is called joint variation. Now, for joint variation, we have relations. So if you have y varies jointly, if you have y varying jointly as, let's say, x and z. In other words, this is just a relationship where one variable varies directly with two or more variables. Okay? Varies directly with two or more variables, or product of two or more variables. So they vary directly, like the way it is here. So when we say, let's say y varies jointly as x and z, this is what it means. Meaning it's going to be y is equals to x, z, but of course there's always a constant variation. So k, x, z. This is the formula for the joint variation. Okay, so let us have a question. So we are saying the question is, if A varies jointly, as B, if A varies jointly as B, and the square root of C, and A is equals to 21 when B is equals to 5 and C is equals to 36. The first question is find K, the constant variation. So to find K for the constant variation, we know that this varies jointly as B and the square root of C. Now at this point, there's something that I need to explain. That is these terms. You find square root. Now square root, let us say square root of, or let me start with square. Let's say x square, just square. It's like this. So x squared is just x raised to the power 2. Then of course square root, any variable here square root or anything square root, it just has to be under this symbol. So if we say x is square root of x, square root of x, it means it's under this square root. Then cubic, it means x to the power 3. But of course, cubic root is under this symbol. Cubic root of, let's say, x. This is the cube root. The cube root. Okay, so these are very important to understand them because they are usually part of the questions. So square, when you hear of square, varies dialect as a square is just raised to the power 2. Varies, let's say inversely dialectly as a square root, just know that it's under that symbol. Cubic, just know that is that. Cube root, of course, that. So very important to understand. So here what we are told is that it varies jointly as B and the square root of C. So what it means is that A varies jointly as B and the square root of C. Okay, this is the equation. The formula is going to be B square root of C. This is what we are going to use to find. Now in front there should be a K. So that's the one that we are going to use to find K. So I'm saying A is equals to 21. So A is equals to 21 equals to B is equals to 5. Then of course the square root. So this is 36. Now here we can say 21 equal to 5, 36. Square root of 36 is 6. So this one is going to. So let me just make some modification here. Let us say A is equals to 60. Okay, A is equals to 60. So I want the number that will not give us a decimal. So what are we going to have? We are going to have 60 equals to 5 multiplied by 6 is 30. There's K, please. 30K. There's K in front here. So what are we going to do to find K? So here we are going to find a K equals to 2. Okay? I guess there's no problem. So that is how we are going to find the K. Now, here just this part, maybe another question. Let me just try to clean this part. So we found our K to be 2. I guess you've taken note. Now, what happened after we found K? In most cases, you find the follow-up questions. So now, after finding K, it's very important that you put it in the formula. So we had A equal to B, that is K, square root of C. So since we found K, this one is going to be A is equals to 2B square root of C. So this is the one that we are going to use to find the follow-up questions. So the next question is find A when B is equals to 9. Find A when B is equals to 9. And of course, C is equals to 100. Let us find A. So to find A, we are going to use this one. So A is equals to 2. B we are saying is 9. Then C is 100. So square root of 100. So this one is going to be A is equals to 2 multiplied by 9 is 18. Then multiplied by square root of 100 is 10. So A is therefore equal to what? This is going to give us 18. That is A, if I'm not mistaken. Then find C. Find C when A is equals to 70, B is equals to 25. So you're saying find B when A is equals to 70, then C is equals to 25. No, find C. Find C. So you're finding C here. Let us find the C when A is equals to 70 and of course B is equals to 25. So you're still going to use this one. So we have A, we replace with 70 equals to 2. B is 25. Then of course we are finding C. So what are we going to do? So here we multiply, it's going to be 50 square root of C equals to what? 70. Now let me just bring this one here. We can say 50 square root of C is equals to 70. Here we can divide 50. So we get rid of this. We remain with square root of C is equals to 70. 70 over 50 can be reduced to 7 over 5. Now, to get rid of this square root, we are going to, the square root is just the same as C, 1 over 2. So if we multiply it by a 2, which means we square this, we are going to get rid of the square root, which means also the other part, we square it. So therefore, C is equals to 7 square over 5 square, which is C is equals to 49 over 25. Now, I don't think you are going to find a question that is going to give you such an answer. This is not just a well thought up question to give us the accurate answer. Looking at this paper or looking at this part comes normally in paper 1. So wouldn't be given something that is complicated. But I think what is important, if you followed the steps, and of course up to this point you are able to do something. So that is how you look at this one. So joint variation, they vary jointly, directly with 2 or more variables. Okay. Then of course partial variation. So partial variation, we have a relationship where one variable varies directly with the other, and of course inversely with the other. Okay, varies directly with one variable and inversely with the other. For example, if we say y varies directly as the square of x and inversely as z, and y is equals to, so in this case y is equals to 2 when x is also equal to 2, z is equals to 24. The first question is find the constant variation k. So we are finding k. Now when we say inversely, I mean partial variation, we are saying y varies dialectically as square of x. Remember, square. So it means varies dialectically as a square of x and inversely as z. So it will be like this. But of course, in terms of the formula, it's going to be kx square over z. All right. So now they are saying find k when y is equals to 2. So 2 is equals to k. X is equals to 2 as well, but it's square over 24. This is going to give us, when we cross multiply there, this is going to give us k 4 or 4k is equals to 48. Divide 4, divide 4. K is equals to 4 into 48 is just 1, 2. So the answer is 12, the value of k. That is how we find the value of k. Then now they are saying find the value of y and find the value of y. So I guess there's no problem up to this particular point. I can remove this. Remember, our k is equals to 12, and we are going to write the formula that we are going to use in the next one. Okay, of which we just replace in the one that we use at first. We just replace k. Okay, so y is equals to 12x square over z. So this is what we are going to be using going forward. They are saying find y when x is equals to 9, and of course z is equals to 27. Let us find y. So we use this one. So where there's x, we put 9. So 12, 9 square, which is the same as 9 times 9 over 27. We can write it as 2. Is it 2? 3 multiplied by 9. So that this and that cancels. Then we have 3 into 12, which is 4. Y therefore is equals to 4 times 9, which is 36. Be able to confirm this if what I've done is correct. All right. So if you happen to find some questions that are difficult in variation, make sure to bring them on. I'll be able to record a full lesson on this one, answering some more past paper questions, as some of the videos on variations are already out there on this platform. So make sure you check them out. But maybe I should be able to record a new one, catering some more questions and different problems. Otherwise, this is where we end. But please, if you are interested to join online lessons, you can contact the number 0976 402563. We also offer physical lessons. We are found in Lusaka. In Lusaka, you can find us in Kabwata. That is just near Kabwata Primary School. So when you are getting there, you can just get in touch, the same number, and of course, we'll be able to give you directions. Otherwise, see you in the next class.